Ladies and gentlemen, here we go, day 2 of section 1, chapter 2. We're going to talk about in this video, how do you evaluate functions? And get ready, it's going to be a lot of fun. You're going to be introduced to something called the Function Machine 3000, where it's going to be grinding things up and spitting things out. It's going to be amazing. Let's rock and roll, let's do it. Alright guys, a function, remember, by definition, is just nothing more than a relation. That is some type of a rule that actually takes the input value, whatever it is, we call it domain, remember, or x-coordinate, and it pairs it with exactly one and only one output. We call the range or y-coordinate. If you come down here, you'll see this one right here, remember, was no good because this input value is trying to be mapped and is being mapped to two different places. That cannot happen. Now, that's a relation, but it is not a function. Come down here, you'll see these two things right here, even though they're going to the same place, is certainly fine. Because each input value is not trying to be mapped and is not being mapped to any more than one. So that one right there was a good deal. Okay? So let's come back to one where we just said let's graph a linear equation. And you can do this many ways, but we talked about this in class where we make an XY table. And I love this, how they do this in the book. They put choose your X. I love it because that's exactly it. You can choose any X you want it to be. I chose these 5, but you could have done 1/2, 2.6, 8 million, 32.5463. You choose anything you want. You want them to be nice numbers, but choose anything you want. So basically, if I just look at this one right here, this is what you're doing. You're saying, hey, if X happens to be -2, you have to then come over here and evaluate what X is going to, what Y is going to be whenever you take this -2 and plug it right in there, and then evaluate that equation for Y. So if I did that, I'll take this -2, I'll plug it in there. That would give me a +4 plus 3 would output to me a 7. So basically, this is all you're doing. You're taking and putting your domain value, -2, into this rule, which is -2x plus 3, and it's mapping it over here to the range, the y-coordinates, to 7. If I put that in my coordinate plane, which is ultimately what we're doing because we're graphing it, I would put it at -2, here's 6, here's 7. Sorry, it's a little off the graph, so right about there is -2, 7. So, I'm going to do the rest of this real quick. I'm going to speed up the video, take out my voice, but you can do it as well. And you can just kind of follow my mouse and see what I'm doing. So there you go. So I've just done all these points, and all it did is, again, it just took a -1, and this rule mapped it over here to 5. 0 went to 3, 1 went to 1, 2 went to -1, and all it created was this nice little line right here of all my solutions, which should make sense because we just graphed a thing called a linear equation. Now here's a question. Is this thing, here's the word, a function? Well, if we use the vertical line test, it would pass the vertical line test with flying colors because no matter where I put a vertical line, it's only intersecting it at one spot. So absolutely, it would be a function. That being said, these things called linear equations are sometimes called linear functions because here's why. You're never going to put in 0 to this equation and get out something different than 3. There's no way it's possible. You put 0 in here, every single time you're going to get out 3. You won't have 0 go up to 5 and then come over here and say, oh, I also get 3. Won't happen. That's because it's a function. Now, let's roll into what this thing is called function notation so you get the idea, and I'll give you an example. So if you take this equation that we just did, and you see this little box over here, I'm calling this my equation machine. Yeah. So my equation, as you see in here, -2x plus 3, that is my rule that I put into this equation machine. You know what? Check this picture out. What is that thing? Yeah, if you show your parents this video, they'll know that this is an old Apple computer with a little monitor, and this little thing right over here, you probably have no idea what that is, but that is actually called a 3.5-inch floppy drive. Means nothing to you. Actually, that's not even right. I think it's 5 1/4. I think it's called a 5 1/4 floppy drive. Look at me, I don't even remember. I just remember what it looked like. And anyways, if you treat these equations like computers, where this thing right here is your program, and you're going to input an x value, which, by the way, yes, that input of the x value, we call this domain, remember? Our domain. And then it's going to put, say, for example, I don't know, if x was, like we did before, -2. If I put -2 into this equation machine, it's going to insert that -2 right here for the x. It's going to grind it up, and it's going to output something. It happens to be a y, or, as we know, the range. So that's really cool, but here's the scoop. When I put -2 in there, this thing would output whatever it is. Let's relate that, though, over here to what we call a function notation. And you'll see how this relates here in a little bit when we evaluate functions. So this is the scoop over here, very simple, same concept as what we know. But function notation is this. When you take an equation and you write it, instead of letting y be the thing that it's equal to, you write it as f, parenthesis, and then x. And you're going to say, what in the world is that? Well, these two things are actually interchangeable. Y is the same thing as this thing, f of x. And I just said it. You read this as f of x. And as a definition, which you should write in your notes for sure, basically this is what it is. It's asking you a question whenever you have something written like this in the following way. It's saying, hey, what is the value of the function when x equals whatever it tells you? So it's asking you what the output value is. What is the value of the function, aka the output value, aka whatever y is, aka our range. I've said aka enough. So that's what it's asking you. What is the value of this function when I input, domain, input something? So you can rewrite this thing right here in the following way in function notation. You can write f of x and my rule 2x plus 3. So that is function notation right there, where you're just rewriting this equation where y, and you're replacing the y with f of x. Now, let's go over and evaluate functions so you get a chance to see how this whole terminology looks and how we actually deal with it. Okay? Okay, so new example. Now I have this value, or this function, -3x plus 2. This right here, ladies and gentlemen, is my rule. It's all it is. Just my rule. So if it's my rule, if it's my rule, this is what I'm going to do. I'm going to take that thing and put it in here as my program for this function machine. So welcome to the function machine 3000. It's awesome. So here's the scoop. Again, up here is all of my x values. It's my inputs. I'm going to throw all kinds of values into this function machine, and it's going to output my y value, aka we know it now as f of x. So what am I talking about? Well, let's do our first one. Let's say I want you to evaluate this function when x is, I don't know, I'm going to say a positive 2. Well, that means this. I am really just asking you to do the following thing. Let's put this 2 in for x. So evaluate this function when x equals a 2. That means I'm going to put a 2 into this function machine. It means it's going to insert it here for x, and it's going to do -3 times 2 plus 2. So it's going to do this, and it's going to output something. And that output is going to be my f of x value, or my f of 2 really, or my y value. So when I do this, it gives me -6 plus 2, which gives me -4. So my value for this particular function, when I input a 2, is going to give me a -4. That's exactly how you would write it. Now if I went over here and just said, hey, here's my equation, and I want you to evaluate this equation when x equals a positive 2, all you would do, substitute it in here, and you would get y equals -4. Oh, look how similar that looks. Oh, I get you. It's just the way that you write it, because now you're saying the value of this function when x equals 2 gives me -4. Whoa. So let's do another one. Let me erase some of this. We'll just kind of go through it. Deal with it. Okay, so what if I say this? What's the value of this function if, I don't know, x was -1? Well, that means I'm going to take my x value, and it's not going to be 2 anymore. It's going to be a negative 1. So I'm going to put negative 1 in here, put negative 1 in for x. Wow. It's going to grind it up. Take negative 3 times negative 1 gives you positive 1, or positive 3. Add that to 2, and it's going to output to you bloop, a positive 5. So the value of this particular program, this particular function, this particular rule, whenever you put in negative 1 in for x, is going to grind it up, and it's going to output a 5. Beautiful. Let me do one more. So what is the value of this function when x is, I don't know, negative 1/3? Woohoo! So now, my input value is negative 1/3. So I put it in there. That's one of my domains, x input. So I have to do negative 3 times negative 1/3 plus 2. Ooh, these cross off. It gives me 1 plus 2, which just gives me 3. So this thing is going to output bloop, a 3. So when I input to this function machine negative 1/3, ooh, it's going to output to me a 3. Now watch this, last thing. If it asks you to turn this then into an ordered pair, as a relation, if you will, ordered pair, and graph it on the coordinate plane, then what you would do is this. The x value is negative 5, or negative 1. The output value is 5. This one, the input value, the x coordinate is negative 3. The output value is what it outputted, what it grinded up and blip, spit out. It's a 3. So ladies and gentlemen, there is your evaluation of functions. Next slide right here that you're going to see is your CPQ question. Good luck. So here you go. Here's the question. Evaluate the following function for 2 questions. And by the way, I didn't say this in the other video, but just so you know, functions can be used, or you can use f for a function. I have no idea why that got so big. Wow, that's weird. Wow, that was really big. So f, it could be f of x, it could be g of x, it could be h of x. So you can use any letter. It's not always f, but these are the 3 that typically you'll see, f, g, and h. Doesn't matter, it's just the actual letter. Regardless, here is the scoop. Let's take the CPQ question and answer these 2. I want you to evaluate this function using the function machine that we just talked about, where the value of this function g is negative 3. And I want you to tell me what that is going to give you output. And the other one, let's make it g in terms of what it's going to be. Let's go 3/4. We'll put a fraction in there. So I want to know what those 2 are going to be. So on your Google form, just write answer to number 1 is that, and then answer to number 2 is bleh. So there's how I put it in the Google form in the same spot. So excited to practice this and mash this in class, evaluating functions. You guys are awesome. Rock on.